Morning, y'all. Happy e-learning flex day part 17 of the first week of February. I'm kidding, obviously. We are moving on and doing a lesson. However, we aren't doing the entire thing. We are only going to do this first little section of evaluating piecewise functions. So don't freak out. You won't do the entire Go formative. Well, you'll do most of it. You just won't do 2 questions. So I'll go over that at the end. But today's learning target, I can write an equation. Nope, we're not doing that actually. That'll be on Monday. This one, I can evaluate functions given an equation. Okay, so what is a piecewise function? A piecewise function is a good old function that has different rules. These are long words. Different rules for different parts of its domain. So that's fancy words for saying that a piecewise function is something that's not whole. So there's pieces of it. So as you go throughout a graph, you have the domain, which is its x's. Try to follow my cursor. As I go here, maybe I have a part of a graph that's down here, but then it breaks, and then the rest of the x values, maybe the graph is up here. So we'll get into that more on Monday. Today will be more of just evaluating the domain and the restricted parts of it and knowing where to plug in values based off that domain. But it's just good to know that that's what a piecewise function is. It's something that's not whole. It is in pieces, and it has different rules for different parts, okay? But really, we're just focusing on these first couple for today, because I just want you to get comfortable evaluating, looking at the domain, and figuring out what you are evaluating for. So this is what a piecewise looks like. You have, for example, this first part would say that this line, 3x minus 5, is what is occurring at this part of the graph. So when x is greater than 4, so here, I'll just jot down a little graph, okay? So here's 4. Okay, as x is greater than 4, so that's to the right of 4. I'm just drawing a line. It's not exact, okay? You have a graph that looks like this, okay? You just have a line over on that side as x is greater than 4. Nice. No one's here. Still got builds. But then you jump down, and as x is less than 4, so anything to the left of this up and down line at 4, you have a totally different scenario. So you have x squared, which, we can kind of draw it in. It looks something like that, okay? So see how it's 2 different pieces? As we're to the left of that 4, as we're to the right of that 4, we got 2 different equations going on. So all we're doing today is figuring out where we're going to plug in, okay? So I'm just going to highlight these guys in different colors. And all we have to do, f of 7, we have to figure out, am I plugging in 7 to the yellow or to the blue? And you determine it by seeing where does 7 fall within that domain. So 7, is it less than 4 or greater than 4? Since 7 is greater than 4, that matches up with the yellow equation, okay? Since it's bigger. See how it falls in that domain of being bigger than 4? That means we're plugging 7 into 3x minus 5. So to get our answer, we'll go 3, change the x to a 7, minus 5, and plug that into your calculator to get 16. That is the answer you will type into Go formative, okay? So you're just evaluating. 4, f of 4. I'm just going to come over here. How does 4 relate to 4? Is it greater than 4? It is not. It is equal to 4, so you have to figure out which equation that would fall into. This has to be bigger than 4, so being equal to doesn't count. But this one, the blue one, equal to works for it, right? So this one we are plugging into the blue function. So I'm going to come down here, and I'm plugging it into x squared. So instead of x, I'm putting 4 squared, getting 16 again, okay? I'll do this one with you, and then we'll kind of jump down, and I'll let you work on those 3. Evaluate -3. I'm just going to write -3, figure out how it relates to 4. In this case, -3 is a lot less than 4. So look at your domain, yellow or blue. X has to be greater than 4 here, so it's not yellow. We are looking at blue again because x is less than or equal to 4. So we're going to plug it into that x squared again. So -3 squared equals 9. That's my solution, okay? So I want you to try to get these guys started, at least maybe trying to figure out which ones you're going to plug them into, okay? So I'll give you a second. Okay, so hopefully you've gotten a little bit of a start. I'll kind of start going through these. I highlighted them again so we can discuss in colors. So here's our domains. For this top one, we need to be, x has to be less than 1, so we're looking at, or equal to 1. So it could be 1, 0, any of the negatives, okay? For this middle one, which is kind of weird, we'll get to that, it's just 3. Whatever answer in here is just the answer is 3. Between 1 and 3, but they can't be equal to 1 and 3. So the only number that would be here was probably 2, because it can't be equal to 1, or it can be a decimal. Somewhere between 1 and 3 can't be equal to them. And then left over for pink is just anything bigger than 3, or equal to 3, okay? So I'm going to look at 10. I'm just going to write it up here. How does 10 relate to all of those? Is it less than 1? No, it cannot be yellow. Is it between 1 and 3? No, it cannot be blue. Is it greater than or equal to 3? It is. It's a lot greater than 3, okay? So that we are plugging into, time for second period, that we are plugging it into that bottom equation, 6 minus 2 parentheses 10, changing it to a 10. So I get it's negative 14. F of 2, we're going to evaluate where 2 stands in this domain. So I'm just going to jot down the number 2. Is 2 less than 1 for the yellow? No. Is 2 between 1 and 3? That's the only number that's between 1 and 3. So I'm just going to jot that down so you see it. That puts us right in this middle one for being, the answer is literally just 3. See how right here we have nothing to plug it into? It's literally just the number 3. That means anything within that domain, the answer is just 3. Okay, you don't actually plug in 2 because there's no x value to plug into here. Okay, last one, 0. Let's just figure out how that relates. Is it less than 1? Is it between 1 and 3? Or is it greater than 3? It is less than or equal to 1. So we're looking at that top one. So my top equation is negative 2, absolute value, and then I'm plugging in 0. 0 plus 1, well, 0 plus 1 is just 1. So absolute value of 1 is 1, so it's just negative 2 times 1, which is negative 2. That's my solution. Okay? All right, last one. We'll just go through it. I'm going to give you a chance again, and then I'll put them up here. Okay, here are your answers. I will then talk through each of them and to show you what I plugged them into in case you got different answers. But if you got it, then you're good. Start on your homework. But if you were a little iffy on them, I'll just go through them really quick. I got my top, which has to be less than 0. Okay, anything less than 0, so we're looking at negatives. The middle, which is anything that's equal to 0. And then the bottom one, which is anything that's greater than 0. So 1, 2, 3, decimals even, just bigger than 0. So 10 is, let's figure out, 10 is definitely bigger than 0. So we're looking at that bottom one, okay? So the bottom one is 0.5x minus 1. So I'm going to plug in the x for 10 and then minus 1. That's how I got it. So half of 10 is 5. 5 minus 1 is 4. Negative 10. Let's talk about negative 10. Where does it fall? Well, it can't be the pink one. It's not bigger than 0. It's not equal to 0. So it has to be less than 0, which is our yellow. Okay, our yellow equation is 2 times x. So 2 times negative 10 to get me negative 20. P of 0. 0 equals 0. We're looking right in that middle one because it's not less than 0 and it's not bigger than 0. So that leaves us with the middle equal to 0, which has an equation this time. It's x plus 5. So instead of x, I'm plugging in 0 plus 5. That's how I got 5. Okay. Last one, 2.48. It is a decimal, but it's a decimal that is bigger than 0. So we're looking at that bottom one again. Okay. So I'm plugging into 0. I'm going to do it right here. 0.05 or 0.5 times 2.48 minus 1. okay? And you just plug it in your calculator. I got 0.24 when I plugged that in, okay? So just figuring out which part of the domain that thing that you were evaluating fits into, okay? Last one we'll do, you won't see something like this on your homework, however, just talking about what input value would give you an output of -6, okay? Symbolically, we're looking at P of what is equal to -6. So what you have to do for each of these is actually plug them in to each of your domain, or each of your equations. But I am plugging into it's the output, okay? So -6 isn't going in for x, it's going in for what 2x, so for the yellow one, what 2x should equal, okay? So we're going to find what x would equal if our output was -6. So I'm going to solve for this, and I get that x is -3. So now I got to compare it to the domain, so I'm comparing it to the yellow, okay? Does -3 being the x fit in the yellow domain? Well, x has to be less than 0. Is -3 less than 0? It is. So far, that one works, okay? P of -3 would equal -6, okay? Let's just check it for the others. We're going to check it for the blue. X plus 5 equals -6. We're going to solve for x, and I get that x equals -11. But look at the domain of the blue. For the blue, x has to equal 0. But we just got that if our output was -6, our x would be -11, and that's a fail because it's not 0. Okay, last one just to show you the point again. I'm plugging in -6 for the output, so what it equals, if you solve for x, you get that x equals -2.5. Compare it to the domain of the pink, because that's the one we're testing. X has to be greater than 0 here, but we just got a negative number. So that one also would be your fail. So the only one that would work here symbolically is -3 would have to be the solution for your output to be -6. Okay? Cool? You won't see like that one on your homework, but it's good to know the backwards thought process of these. Okay? So again, let me explain the homework. It's a go formative like usual. But you are not doing the entire thing. It's going to be obvious which one you will not do. It's the very last one that deals with the graphs. I just want you guys practicing the evaluation. So plugging it into certain piecewise functions, okay? So just do what we did today. Don't do anything with graphs. All right, and I will see you on Monday. This will be due on Monday when you return, because we will pick up piecewise on Monday in class.